Then tomorrow we're going to go back and review, okay? So tomorrow you have a homework check due that only covers law of sines and cosines and the area formulas. And we will start reviewing for Friday's quiz. So I'm teaching something that is not on the quiz Friday, all right? But you can get started on this assignment between now and it's due next Wednesday. All right, you guys, some classes voted to test Friday, so we're testing Friday. All right, the trig identities that you should maybe, hopefully, I hope, I think, already know are these ones on this page. You know that the reciprocal of cosecant is sine. You know that tangent is sine over cosine. Okay. Well, if you don't have these memorized, it's something that would help a lot in getting these identity problems done faster. If you have to look up what every single little, cosecant is 1 over sine, if you have to look that up, that's going to make these miserably painful. All right. Before we talk about the Pythagorean identities, we need to talk about the fact that if you want to square the sine, we don't write it that way generally. If you put it in your calculator, you have to put it in that way. Okay. But how we normally write it is like this. It's just kind of shorthand, so you don't have to write all those parentheses. But does everyone understand that that means the same thing? You're not just squaring the word sine here, you're squaring the function after you, and you're not squaring the angle. Okay. So one more quick thing, if you had tangent squared and you wanted to trade it out for sines and cosines, it would be sine squared over cosine squared. Does that seem okay? And again, this really means the tangent is being squared. All right. The Pythagorean identities are super important. I know if you go to like University of Illinois at Chicago, you have a math placement test that has these on it and you have to have them memorized. I mean, you have to do trig identities on their placement test and you have to know these. Yes, UIC, that's the one that I know for a fact they were on there, but not that I went there, but okay. This one, memorize. Sine squared plus cosine squared equals 1. That's not going to take up that much memory space, right? It's related to x squared plus y squared equals 1 on your unit circle here. Does that make sense? Okay. The other two, I don't even have memorized because all you have to do to find them is take this one that you already know and divide them all by cosine squared. And what will happen? What's sine squared over cosine squared? That's supposed to say tangent squared theta. That was a mess. Cosine squared over cosine squared. And 1 over cosine squared. Okay, we just figured that one out. Well, if we got a new one by dividing them all by cosine squared, what do you think? Take the original one and divide them all by sine squared, and what will we get? One over sine is okay, so we found these two. What you also need to know is that those will get rearranged all the time. I have an example here, sine squared plus cosine squared equals 1. If you wanted to get the sine squared by itself, it would be 1 minus cosine squared. Everybody remember this? If you wanted to get the cosine squared, it'd be 1 minus sine squared. Okay. On your blue sheet, can you make sure you have out your blue sheet and worksheet 30 from the last packet? On the blue sheet, there aren't very many different rearrangements of this. 30 is another reference sheet. The back of it has some weird forms. But I just want you to know the only way that it's written on, guys, on the blue sheet, where are the Pythagorean identities on here? Oh, okay, the top. There's only one form written for each one on the blue sheet, right? This basic definition here that's in the key concept box. But on the worksheet 30, there's all kinds of them. They're including the factored forms. Sorry, I don't know what's happening here. Do you see, it's not exactly like this on the worksheet 30, but it does say things like 1 minus cosine squared could be factored 1 plus cosine times 1 minus cosine, okay? So if you're struggling, look at those versions as well, okay? But know that you have to be able to manipulate those in your head because the blue sheet is the only one you get to use on a quiz, and it just has the basic identities. All right, this is a little bit out of order in my thinking, but they want us to use those identities to solve this. I say, no way, Jose. I don't want to have to learn a new way to do this. I already know how to do this. I just draw. What quadrant am I going to draw this in according to this sentence right here, or this part of the sentence? I'm going to draw it in 1, and I'm going to label which parts 3 and 5? Opposite and hypotenuse, or y over r, whichever definition you like. How do I find the tangent then? I do Pythagorean theorem so that I can find this missing piece, which we're good with just putting down a 4. And then tangent would be opposite over adjacent. Are we good? I didn't need any Pythagorean identity to do that. Okay. These are even easier. How do you get from cotangent to tangent? How do you get from sine to cosecant? Okay, you want a whole test on those? Okay. Now, this one gets trickier. They don't tell us what quadrant it's in. We have to use some clues here. If you started out with this, all students take calculus. Do you remember what those stood for besides what I just said? All are positive. Sine and its reciprocal are positive. Tangent and its reciprocal, cosine and its reciprocal are positive, right? So what does this say right here? Cotangent is negative. Okay, so cotangent can't be negative there or there, right? So I'm down to these two. What does this say? Less than 0 means the sign is negative, so we must be in quadrant 4, okay? Now, while I'm in quadrant 4, I'm supposed to label cotangent negative 4/3. Cotangent is x over y, or adjacent 4 here, opposite 3. Which one of those gets the negative? How do you know? Because it was going down, okay? So that one gets the negative. Do Pythagorean theorem, and we get 5 again. All right, so they asked me to find the cosine, which was just what? 4 over 5. And the cosecant, which is hypotenuse over opposite. Negative 5/3, doesn't matter where you put the negative. Are we okay? So it was just a little tricky figuring out which quadrant, right? But otherwise, it's the stuff we've been doing. Can you try number 4? If the secant is negative, so's the cosine, right? If the cosecant is greater than 0, what does that mean? Positive. So the sine is also positive, because that's the reciprocal. So where is cosine negative and sine positive? Okay, so here was secant or cosine were negative. That's not true over here. Sine is positive, so we're in quadrant 2. Everybody okay? Okay, if this is a fraction negative 4 over 1, where do those numbers go? 4 is the hypotenuse, but the hypotenuse is never negative. And the secant is cosine, so it's adjacent. Does it make sense that that would be the negative 1 because we were going to the left? Okay, if we do Pythagorean theorem, what do we get? We already know the hypotenuse, right? So it's got to be less than 16. Everybody okay? Why it wasn't 17? Okay. Now we need cosine. Actually, we already found cosine, right? Because it was just the reciprocal of that. So that part we wouldn't have even needed to draw a picture for. But tangent, what was tangent? Square root of 15 over negative 1 or negative square root of 15. Everybody okay? Everybody following, or let me go back over something? Okay. The next thing we'll talk about quickly is even and odd functions. If you ever see, and we will see some of these, it'll say the sine of negative x equals, and you have to decide, is it just the sine or is it the opposite of the sine? Okay, this has to do with even and odd functions. If you know that you have an even function, then when I go this way 20 degrees or this way 20 degrees or this way pi over 2 and this way pi over 2, I'm going to get exactly the same thing, right? Because it's got y-axis symmetry. Which functions are even? Cosine and its reciprocal. Okay, these are even functions. So what happens is it doesn't matter if you have that negative, it just goes away. Okay, it says here even functions lose the negative. If you ask me to go to the left pi over 2 or to the right pi over 2, either one are going to get me the same answer. Right, that's not true on the sine and the tangent because they're odd functions, okay? If I go to the right pi over 4 on a tangent function, I get positive 1. If I go to the left pi over 4, I get what? Negative 1. So when you go here to the left, you get the opposite answer. So on any odd function, if I go to the right pi over 2 here, I get 1. If I go to the left pi over 2, I get negative 1. All right, so on any odd function, you can move the negative out to the front. The sign of the opposite, or negative pi over 2, is the opposite of the sine of pi over 2. Not going to have to deal with that very much today. That is on your blue sheet. Can you find it, guys? Just so you know where it is. It says odd and even, right? And it shows you which ones you get to ignore the negative and which ones you got to move it out front. All right. This one is a little bit trickier. Co-functions. For the first time, the words actually go together. Sine, cosine. Secant, cosecant. Tangent, cotangent, okay? These are complementary. Complementary angles. Do you remember in geometry? Complementary, if this one was 30, this one was 90 minus 30 or 60, okay? So the deal is when you have the sine of 20 degrees, it is equal to the co-function of the complementary angle. So it's equal to the cosine of 70. Type it in your calculator real fast if you have it out. Sine of 20, enter. Cosine of 70, enter. Should be in degrees. Yes, they're equal? Okay. So cofunctions of complementary angles are equal. Cofunctions of complementary angles. Now, it seems really cool, and we like never use it, okay? By the way, guys, it's not really as tricky as you think. If you have a right triangle and you do 30 degrees here, and you do opposite over hypotenuse or something, and you go to the complementary angle up in this corner, isn't that the same as adjacent over hypotenuse from that corner? Think about it for a minute. Here, the sine from here is 1/2, but the cosine from this is 1/2, right? All right. We don't actually use this in identities very often. Therefore, it is not a part of your blue sheet. It is on the back of the white worksheet 30, okay? With that in mind, I'm going to show you one example on here that kind of hurts my head. This example is at the bottom left-hand corner. Try to follow, but I promise I would never put this on a test or quiz, all right? It says the secant is -2. The reason this is such a tricky question is it wants to know what is the cosecant of beta minus pi over 2. What is this supposed to be? It's supposed to be pi over 2 minus beta, right? Okay, so they've switched the order here. Switching the order on a subtraction is taking the opposite. So we need to take the opposite of this. To get back to theirs. Well, now you got to go back to the even and odd stuff, guys. Is cosecant is related to sine? Yes? Sine is even or odd? Odd, so we have to move that negative out front. So basically, the cosecant of the opposite of this. So if this was -2, we're going to get +2. Let me try explaining it one more way, okay? I'm not going to ask you this on a test or quiz. Just try to follow one more time here. Trade me for this. Secant is equal to what right here? Cosecant pi over 2 minus theta. Okay, I just traded out that. Did a trig trade. Okay, they want to know this, so we need to do what? We need to change this. Switch the signs around. We need this one to become negative, this one to become positive. Because it's an odd function, that means we got to put the negative out here. If we do that to this side, we have to do that to this side. So we're going to get, okay, cosecant is positive. Because they wanted us to switch it around. Okay, when we put it out here, then we can rewrite it as this. I didn't. Anyway. Yep, it's not good. Just forget we even did that problem, okay? This is the only thing you need to know it for. There's one problem, I think, on the homework like this as well. You can find this. This is not hard. What can you trade this for, guys? Right here. Find that on your notes. This is the complement of cosine. Complementary cofunction of cosine would be sine. This is number 12. It's the only place you need to use one of those. It's not on the tests and quizzes. That's why it's not on the blue sheet, okay? Now, before I do this, finish this question, let's go back and look at the top of this page. It said these are called simplifying or rewriting trig expressions. They want you to simplify them down using trig exchanges and algebraic techniques like substitution, factoring, simplifying fractions. So here are some suggestions from me. It helps sometimes, not always, to rewrite things with only the words sine and cosine. So when you see cosecant, you replace it with 1 over sine. You look for, on that blue sheet, for all those identities or trades you can use. You may need factoring. You may need a common denominator. You may need to conjugate a fraction. What does that mean? Well, I'll show you one at the end here. Not very often that you have to do that. But if you have a denominator of 1 minus sine x, you would multiply it by 1 plus sine x, top and bottom. Okay? Yes. Yep. Conjugates. That's where you've heard that word when we did imaginary numbers. Remember, the conjugate of 3 minus I was 3 plus I. All right. Look for your Pythagorean identities. I don't know why that's not on my list here. Okay? Look for your Pythagorean identities. The big thing with those is it has two things to look for. It's got to have a squared, right? All those Pythagorean identities had squareds on them. And it's got to have a plus or minus. Okay, if you see a plus or minus and a squared, then think maybe I need a Pythagorean identity. All right, one more thing. Does this simplify? Can I simplify that? No. That does not simplify. If I write this, does that simplify? Not really. But could I rewrite that? How could I rewrite that? A over A plus B over A, which could be rewritten as 1 plus B over A. Okay? But this, you can't do that too. You can only do that when there's a single denominator. You can put it under each one. All right. Those are my hints. Ready? We're not going to get through all these. We have 20 minutes left. Pick one. Number 1, like number 6? Okay, we'll do 6. What do you want to try here? You want to distribute first, or you want to change to sines and cosines first? Okay, so if we change, this will stay cosine. We still have a parenthesis. What's tangent? Okay, it's 1 over cotangent, but that doesn't get me anywhere, right? Let's go with sine over cosine. Plus cotangent, which is no. When I'm grading these, if you don't have all the x's, I'm fine with that. Officially, you're supposed to have an x, but I know it's a lot of writing when you're doing these, so I often lose my x. Okay, what do you want to do now? Okay, I'm going to show the distributing step. If you choose to skip writing some of this, I'm okay with that. This is not a proof. This is a simplifying. You still should have work, but I'm not grading on is every step exactly the same as mine. Like if it said prove, then you have to have steps I can follow completely. All right. Now what? Okay, this one, I just get a sine x. Okay, and it only multiplies to the numerator. Somewhere earlier today, people were saying, well, why doesn't there go on the denominator too? When you multiply 2 times 1/3, you just get 2/3, right? Just goes to the numerator. So we get cosine squared over sine. Can we cancel the signs? No, that's a plus, not a times. Okay, cosine squared equals 1 minus sine squared, but I don't think that's really getting us anywhere. I think we need to combine these. What do we need to do to be able to combine them? We need a common denominator. We can't randomly decide to do anything other than multiply by a form of 1 here, right? What is the form of 1 we're going to multiply by? Sine x over sine x, so that we get what? Okay, sine squared x over sine x plus cosine squared x over sine x. Why was that a good plan? Because now when we add the top together, that becomes a trade of 1. And we keep the denominator. And 1 over sine is cosecant. In calculus. Then it's just fun puzzling. Pick another one, guys. 7. Okay. Anybody have a suggestion for starting this one? I don't think I would suggest moving everything to sines and cosines because then you're going to get a complex fraction. Remember my hint up at the top? But they're not reciprocals, so that's not good. Okay. Okay, I'm going to try what Basma's talking about here. She said, this is a sine x times a 1 over cosine, right? Do you want me to mess with the bottom too or not? I think let's leave the bottom for a minute. This is not the way I did this, but I think she's got a great plan because what does this become back here? A tangent, right? Sine over cosine is tangent. So then we end up with tangent x plus tangent x over cosecant x times tangent x. What's a tangent plus a tangent? Not a tangent squared. 2 tan x. Now we don't have any adding anymore, right? So now that it's multiplication, what can we do? Divide. And when we divide, what happens? Do we have 1 tangent left? This is 2 times the tangent. So when we divide the tangent out, all we have left is the 2. Because we're dividing, not subtracting. So 2 divided by 1 over sine, because cosecant. So if we divide, we do what's the fraction? Yes. Okay. I'm going to really fast show you what I did when I did this problem. See if you like this any better. I don't know. I'm going to leave out my x's, okay? I split it up and put each one over the denominator, okay? Then I canceled these, so I had 1 over cosecant. What's the reciprocal of cosecant? Okay. Over here, I said this is sine. This one is 1 over cosine. This one is 1 over sine. And this one is sine over cosine. Well, what do I get up here? Tangent. What do I get right here? Tangent. So I have 1 over the reciprocal of sine, which is sine. So I don't know. Do you understand that almost all these you can approach different ways? Okay. Pick another one. 11. All right. This is kind of messy because that 1 out there we can't really can't do much with. So I think we should just work with this piece. What do you want to try? Let's get rid of tangent squared. Is that an identity that we could get rid of it with? Not, a Pythagorean identity? Not changing it to sine squareds over cosine squareds? What else could we do? Secant squared minus 1? Is that what it is? Oh, then we got something similar in the denominator, right? So 1 plus, that would trade for a secant squared minus 1, you said? Now, we got to be a little bit tricky because we can't cancel, right? Because of the pluses and minuses. Yes, which is, Kirsten also said you factor. This is like an n squared minus 1, right? Factors n plus 1 and minus 1. So if we take that and make it secant of x plus 1 times secant of x minus 1, it's over the top of 1 plus secant of x, which is exactly the same as what? Yeah, secant plus 1, secant plus 1. So what's left? That one actually wasn't that bad. I don't know if you would have thought to try that. Some of you did. Curtin was right on top of that. All right, what else? Do you want to finish 12? This one isn't bad. It's sine divided by 1 over sine. So what does that become? Okay, so we flip this over and it becomes sine times sine x over 1, which is sine squared. Yes, you guys are going so fast. You're leaving everybody behind here. Because would you rather have to differentiate this in calculus or just know that the answer is 1? All right. Yeah. What else? 10 more minutes. 10? Okay. I don't think I want to foil this together, maybe. Can I trade this for something? What is cotangent squared plus 1? Oh, I don't know what that says. That's a squared. Okay, what is secant squared minus 1? Okay, now what? Which would be? Okay. I heard about 5 or 6 of you doing okay. Anybody lost? Yeah, I know. Some people are just, like I said, if you don't have those definitions memorized, it's really, really tricky. Okay, we did 11. We need to go back to 9. Okay. I don't think we have a choice but to FOIL. Do you want to rewrite them as sines and cosines or FOIL first? FOIL first? Okay. So if we FOIL, we're going to have secant of x times cosecant of x. Yeah, I don't think it matters that much. Then we're going to have plus a secant of x times 1, or just secant of x. Then what? Minus the tangent of x that is being multiplied by a cosecant of x minus the tangent of x. Well, I think they're going to anyway. This is 1 over cosine times 1 over sine plus 1 over cosine minus sine over cosine. Oh, I'm losing x's left and right. Times 1 over sine minus sine over cosine. Did I mess up anywhere? Okay, Well, that's not really looking as exciting as I had hoped. Okay. Then this is a 1 over cosine, and this is a 1 over cosine, and it's being subtracted, right? So that's gone. That's 0. What else? Yeah, this is 1 over cosine times sine. Yeah. Emerald says we need a common denominator. We can't cancel because there's a minus in here. We got to multiply this by sine x over sine x so that we have a common denominator. So we'll have 1 minus sine squared over our common denominator, which is a cosine times a sine. That's a Pythagorean identity, right? 1 minus sine squared is cosine squared. So if we cancel the squared with one of these guys, I don't know. Did anybody try it without foiling it first? Did it go faster? No? All right, what do we have? 8? Okay. Oh, what is a 1 plus tangent squared? So then I have a cosecant squared over a secant squared. Let's write that out. 1 over sine squared is being divided by what's secant squared? Okay. So I took the top and I wrote it out as divided by the bottom. And when we divide, we multiply by the reciprocal. And cosine squared over sine squared is cotangent. The bottom dollar. I guess so. Yeah. That makes sense. 14. All right, guys, this is tricky. I don't think I would put these directions on a test or quiz, but this does turn out much nicer if you don't have the fraction involved. But to get rid of the fraction, remember I talked about conjugate? What would the conjugate be of this denominator? In other words, just change the sign. Secant of x plus tangent of x. All right, if we do that top and bottom, that's legal because it's just a form of 1, right? Okay. Let's worry about the denominator for a minute. Secant x minus tan x times secant x plus tan x is like x plus y times x minus y becomes what? Secant squared. Everybody okay, or 90 to go through that? Secant times secant is secant squared. Secant times tangent, positive. Secant times tangent, negative. Those would disappear. Yes, secant squared minus tangent squared is 1. So did we get rid of the fraction? Yes, we did. But the numerator, yes, if we distribute here, what Miranda's saying is we have cotangent times secant. We'll deal with that in a second. Cotangent times secant plus And then it says cotangent times tangent. Well, aren't those reciprocals? So when you multiply them together, you get 1. Okay. Now, I'm going to we're going to say the denominator is now 1. Okay, this became a 1. So we got to deal with this top still. What do you want to do? Cosine over sine times 1 over what's secant? I'm rewriting this in sines and cosines. And we get 1 over sine, which is no fraction anymore. No, it's not squared. Yes, that happens all the time, guys. When you see a sine minus sine x minus 1, you want to trade it for a cosine. It only works when there's squareds in there, okay? All right. If anybody, I have run a couple copies of the book assignment. If anybody wants a worksheet that has the book assignment on it.